Hi YouTube, I hope you all guys are doing great. In this video, we are going to see caching in LLM, which is also known as LLM caching. So we all know caching is a process of storing data in a temporary storage area, which is called cache, to speed of access to the data in the future. In the context of LLM, like langchain, caching can be beneficial for a lot of reasons, like cost saving. Okay, like by caching the response from the LLM provider, you can reduce the number of API calls. What I exactly want to say is, let's suppose this is an LLM, okay, whatever it is, like GPT 3.5, Turbo or Instruct 4, whatever it is. Okay, now whenever you ask a question like in the form of prompt, like you give a question and it made a API call and it gives some answer. Okay. Now, if you still ask the same question, then is there a requirement to to do a LLM call? Because it will have some cost, it will take some time. So, is it worthy to call LLM again? Uh, um, I don't think so. Okay, but it also depends upon use case to use case. For example, you have developed an LM based app for your company, okay, where it's kind of like a RAG app, okay. So if you ask a question to this LM based app, which is based on your office data or your company data, now if you ask a question like who is the um, lead HR, okay, so let's suppose it made a LLM call because it have a heavy context, okay, from where it will try to extract the answer as we have developed a RAG based application. Now the answer of who is the lead HR, it went to the LLM and then it answered something like maybe some name like maybe um, John is the lead HR. Okay, now if someone asks the same question like who is the lead HR, I don't think so that we should have an LLM call because the answer will be always remain same. But let's suppose someone is asking like some question like lead HR question mark. This also should return John. Okay, it should not make a LLM call or some question like tell the name of lead HR. Okay, still there should not be a LLM call because all these three questions are semantically similar. Okay, so all these three questions are very semantically similar. Okay, because they all have the same meaning. In this case, we don't have to make an LLM call. Okay, so this is very important. Okay, if you have stored this question and this answer in cache, and only there are some caching strategies where if you encounter the same question, like the same one, who is the lead of HR question mark, then only it will give the answer. So that's not the power of cache LLM using caching in LLM. Instead, we should have semantically similar because all these questions are semantically similar. So they should use this cached answer, which is John. Okay, so this is a case where caching is really helpful. But in some cases, caching is not that powerful for generative tasks. Let's suppose you are trying to ask a question, tell me a joke to the LLM, and it is answering with a joke. Now, if you ask again, tell me a joke, what you want to listen? Just tell me honestly. Do you want to listen the same joke? I don't think so. We will get bored. In this case, we want a new joke. Or I say joke, question mark. Again here, I don't want this joke. I want another joke. So in this case, caching is not important. So it depends from use case to use case. Okay, so I think I have said enough. Now let's see. We have just saw that it can reduce the cost. Okay, it could reduce the time. Okay, I will show you some use cases where we will ask some questions, and initially, without using LLM, without using cache, it will be taking 1.3 seconds somewhere, or maybe 3.3 seconds. But if we use caching, and again if we ask semantically similar question, it will just take 0.04 seconds or 0.06 seconds kind of. So there will be huge reduction in the um, time. Okay, so also performance improvement, like caching can significantly speed up your application by reducing the time it takes to fetch a response from the LLM provider instead of waiting for a response from the provider every time. The application can quickly retrieve cache response, leading to a faster overall performance. Okay, so I have just given you example, and I have cleared like when cache can be important, when the cache can not be important. Okay, but definitely in RAG applications, cache is really important, and it reduce the cost saving, and it increase your like query per minutes and all things. Okay, so overall, caching is valuable technique for improving both cost effectiveness and performance of applications that rely on LLMs or similar services. Okay, so let's see a basic demo. Definitely, you can go to this website, which is just go and search LLM chaining integrations in LangChain. Here you can see a lot of cache are there, like in-memory cache, SQLite cache, Redis cache. Okay, and Redis has two type of cache, like standard and semantic. This is one I was talking about, the semantic cache, which is the most powerful one. Then all there are tons of different providers: GPT Cache, Memento, SQL, Chemi, Cassandra, Astra. Okay, so but all have the same concept. So if you just know one of them, so you may be familiar with other ones also. Only the syntax changes. Okay. So first of all, let's see about the in-memory cache. Okay, so let me go to my turbo. Okay, so let's see. First of all, let's see that if we are not using any kind of caching, what will happen. So I'm just, these are all our notebooks, and I will be making it available through Git in the description box. So first of all, I'm just installing LangChain and OpenAI, because we are going to use LangChain and LangChain OpenAI. Okay. So from LangChain OpenAI, I'm using OpenAI because I want to access this instruct model. So I'm also importing time and OS, just to OS to set the OpenAI key. Here you can enter your OpenAI key. And if you don't have any OpenAI key, just use your Hugging Face model. It's completely free. It's not like if you are using OpenAI models, then only you can learn these things which are on LangChain. You can just add your Hugging Face models, as I have taught in my basic lectures. You can go and watch it. Now, if I'm asking a question, so this is basically an LLM, which is which we are using GPT 3.5 Turbo Instruct, because it is a slower model, so we can see the response very. It will take some time to give response, so it's better to use this model. Now, if I ask a question, what is the capital of Japan? This is start time, end time, and here we are asking the question. This is the way we invoke a question under LLM API invoke. Okay, so it asks a question, just it's a basic syntax. Okay, so here you can also see the input is to the runnable, and basically it returns the output of the runnable. Okay, so print answer, and also we are making the time like n minus start, which will give the how much time this question is taking. So here the capital of Japan is Tokyo, and time is it is taking 0.96 seconds somewhere. Okay, so without LLM caching, it is taking, I think, a lot of time. Like 0.9 seconds is also huge time. Okay, not huge time, but just for a simple questions, it takes some time. Okay, now let's see caching. Now onwards, I will just follow the same pattern. Again, I am just installing LangChain OpenAI, and just here this is the cache, like globals import set LLM cache, because we want to set the LLM cache as globally. So that's why we are doing langchain.globals import set LLM cache. Now you might be wondering where I have seen all these things. So here it is. Okay, if you go to this website, they have properly documented it. Some sections may be outdated, but you can just correct it. Okay, so again, we are using OpenAI. We are trying to use in-memory cache. So we have just imported in-memory cache. All are in langchain.cache. Okay, then time and OS. We are setting the OpenAI key. We are using the same model. Now, set LLM cache. So it will set globally a LLM cache and it will be in memory. So as long as the program is running, it will be good. But definitely it will have less amount of space. So it is not that good, but in some case it can be helpful. Okay. So question, what is capital of Japan? So initially it is taking 0.7 seconds. Okay. So every time I will follow the same thing. I will not repeat it. First of all, there will be question, start time, and it will record the starting of the time at this instant. And then we are doing LLM OpenAI.invoke. We are asking this question. LLM OpenAI is the whatever models you are taking. You can also use Hugging Face model. Then end time is equals to time minus time. Okay, time dot time, and then we are trying to find the result and the answer. Sorry, the time taken. Now, see, it gave an answer Tokyo to the question, what is the capital of Japan? Now I am asking another same question, what is the capital of Japan? Now here you can say the time taken is 0.0 point 0 because it extracted from the cache. There was a cache hit. Basically, if you don't know what cache hit and cache miss, it's like whenever we ask a question and if it is present in the cache, so it retrieves the answer from the cache only. So it is called a cache hit. But if the answer is not present, the question, if the key is not present in the cache, we call it as cache miss. Okay, so it is a cache hit case. So again, it is taking the same answer, Tokyo. Okay, if you know, if you ask to the GPT 3.5 Turbo or any generative models, so most probably every time the answer will be not same. But if you are getting same answer because it is taking out from the cache. Okay, now, if we ask same question again, okay, not the exact same, but semantically same, like what is the capital of Japan and Japan capital question mark is same. But now, if you see interestingly, the time taken is 0.8 second, means it is not extracting from the cache. It is a cache miss condition. Okay. Then if we again ask a question like capital of Japan, now here you can see like this is capital of Japan. This is all semantically similar. All three questions are semantically similar. What is capital of Japan? Japan capital, capital of Japan. But again, it is a cache miss case because it is taking 0.7 seconds. So what we are extracting from here is whenever we are using in-memory cache, so it is having a cache, but actually it's not semantically similar. So it's not that useful because you don't know, like some person can ask question like what is capital of Japan, someone can ask Japan capital, someone can ask capital of Japan, but all three questions are semantically similar, so answer should come from cache only. So this is a negative point of in-memory cache. Okay, so this was about in-memory cache. Now let's see what is SQLite cache. So if you go here and just read it, like there is no theory, you can just run it, and that's the best way also to practice. Okay, so let's see the SQLite cache. So again, we are doing the langchain OpenAI. Okay, all things are same here. Just we are using, initially we were using the in-memory cache, but we are now using SQLite cache, so we are importing it. All remaining are same. Here, set LLM cache, again we are globally setting this, and SQLite cache database path langchain.db, so it will create a langchain.db kind of thing. Okay. Now, if we ask what is capital of Japan, so it is asking from LLM because it is a cache miss case. So because we are asking this question for the very first time, it will be taking 0.9 seconds. So all the questions and the answer will be stored in this langchain.db. Okay. Now, if we ask the same question, what is the capital of Japan? Here it is a cache hit case. Okay, because we are asking the same question, exactly same question, so it is taking 0.0 second. But again, if we ask Japan capital question mark, it is taking 0.7 second. If you ask capital of Japan, it is again taking 0.8 second. So here what actually is the advantage is that all the data is not stored in memory, but in external DB, which is langchain.db, which is of type SQLite. So it is better that if your program will even stop, you can retrieve the cached items, but it is not semantically similar. Okay, means if because again this question, and this question, all three questions are semantically similar, so the answer should be same. Okay, so again it is not supporting semantic cache. Now let's see one of the my favorite one, which is Redis cache. Okay, because you can store it on a server, and definitely Redis is highly fast for this kind of caching things. Okay, so again we are trying to use here from where I have learned this. So here you can see the standard cache of Redis, which doesn't support the semantic cache, but we also have a version of Redis which supports semantic cache. Okay, so we are using the Redis semantic cache. So langchain.cache Redis semantic cache, because we want to use the Redis semantic cache now. Also, we need some embeddings model. Okay, you can use any embedding model, be it OpenAI or Hugging Face, any kind of. Okay, why we need OpenAI embeddings or any kind of embedding models? Because to search semantically similar, we need embeddings. Okay, if you don't know about embeddings, again you can watch my basic videos. In simpler words, whenever you are having some information in natural language, we convert into numerical representation, which is called embedding, so that it can be presented on a vector space, and we can have some similarity search. Okay, now again we are using the same model. Now set LLM cache. Here we need two things. First one is you should have Redis in your system, or wherever you have deployed the Redis. Okay, and it should be in a running condition. So here you can see I have installed the Redis. So I am just using the Redis CLI. Okay, so I'm using the Redis CLI. So once you install the Redis, okay, I'm not going to describe you or show you how you can install Redis, how you can install the modules and all things, because it will be a very long video, but you can easily find it in the internet. I'm using Windows. If you are using Linux or Mac OS, it will be quite easy. If you are using Docker, it will be much more easier. Okay, but and definitely with some hard times you can easily install and run a basic server. Okay, but if you are facing some problems, you can post in the comment. I will definitely help you. Okay, so how to start a server? Just Redis server, and how to start the CLI? Redis on dash CLI. Okay, so I'm in the CLI. So here you can see like which module I have installed, like module list. So these are the models I'm working on. So initially, if your model list is showing empty array, so you might face some challenges. Okay, so I have faced that challenge, so that's why I'm telling you. Okay, so now in our, let's see what we have in our keys. Okay, so these are basically some I have already used the semantic cache of Redis, so that's why these are the key. Well, basically it's stored in a key and value form. We will just see it. So these are the some cached values that we have stored earlier. Okay, let's see. So to run it, as my Redis is currently um, basically working on this, basically it is deployed on this server, it is running on this server, so I have passed the server. If you have hosted your Redis somewhere else, you can also uh, add the Redis URL, and then you can just pass any kind of embedding models. Okay, so here you can see like what Redis semantic cache take. It takes three parameter: Redis URL, embeddings, and score threshold. So it's like score threshold is like something like the much, or like it should be like around 0.2 to 0.5. So it's like if you are, if let's suppose you have stored some values like some question and answer in your Redis cache, and if a new question enters, okay, and if your score threshold is like 0.2, so if the new question and the already stored question are very semantically similar. So it will not store that new question into your semantic cache. Instead, it will basically just what you can say, like it will directly give you answer from the cache. Okay, because already the answer of that question is stored there. Okay, so that's why you can also pass score threshold, and it is a good practice to pass the score threshold. By default is 0.2, so I have not passed it. It worked fine for me, but you can pass it. Okay, so now we have a question: what is capital of Japan? So the answer was Tokyo, and the time taken was 3.3 seconds. Okay, as soon as you will ask the question, you can just type keys here, and you will see a new cache will be added. Okay, so it will take 3.3 seconds. Now, if I'm asking a similar question, what is the capital of Japan here again? So it is taking 0.9 seconds. It will not take 0.0 second because obviously you have to bring that question from the cache, which is in a server. So it will take some time, but see the difference. It was taking 3.3 seconds. Now it is taking just 0.9 seconds. Now, if I ask Japan capital, surprisingly, you can see now it is taking 0.4 seconds. Okay, why? Because this question are semantically similar. We have never seen this as of now, like in memory cache, SQLite cache. We have never seen this. But this is the power of semantic cache. Okay, the question need not to be exactly similar, just we want semantically similar questions. Now, if you ask a question, capital of Japan, again it is taking 0.4 second and the answer is same. So here you can see like how these three questions were completely different in verbiage, but they are semantically similar. Because if you ask a human being, they will definitely say that okay, all these three questions are just they are having different. They are just a rephrased version, but actually the motive of every question is to find the same answer only. Okay, so see how we can just have this semantic cache. Okay, so definitely there are a lot of different things going on. Like here you can use in-memory cache, SQLite cache, Redis cache. Okay, GPT cache, Memento cache, all are like that only. If you want to use GPT cache, here is the code, you can just use it. Okay, at the end also there are some optional chaining options, like how you can off, like if you don't want some cache, like here you can say see optional caching. So if you want to if you don't want cache, okay, if you, let's suppose you have set the cache globally. Here we have set the cache globally, set LLM cache. Here we have set it on the cache globally. But if you make this kind of cache false for any models or for any models or LLM chain or something like that, so it will override the global settings and there will be no cache enabled. Okay, so this is how caching happens. And definitely I have given you a scenario where you can think like where caching is important and where caching is not important. Okay, so in this type of RAG applications where the answer should be not different every time, okay, then you can use it. But if you want generative things and you want different answers every time, then definitely um, you should not use cache. Okay, I was also going through this Redis vector library. It is quite very good. Okay, so I hope this you should also use for semantic caching. Okay, so it also supports semantic caching, index management. So nowadays, even it is Redis or even it is Mongo, all are supporting NoSQL data as well as the semantic cache. Or also you can use this platform as vector store. So it's good that even if you use just one service, you can find all things. So what I was trying to say is like Redis VL semantic caching. So I just search it and go to the semantic cache for LLMs Redis VL. So here you can see how you can use this Redis VL for semantic cache. I think a lot of data is outdated, but definitely if you struggle a bit and do a googling, you can easily use it. Okay, here one of the best thing I have also found that um, you can also set the TTL, like after how much time whatever cache you have stored, it should be evacuated. Okay, like after let's suppose you asked a question, it went to the cache, and after if you have set this TTL to 5, so after 5 seconds that cache, that key particular question and answer will be erased. And a lot of I found it pretty good, like you can also add prefix, suffix. Okay, so here it was like name, you can also name your cache and prefix. Okay, you can also have distance threshold, so it's good. You can have a look into it. Okay, but the basic functioning is same. Okay, it will also use the Redis server directly, because you have to pass here also the Redis URL. Then also you can use this MongoDB for semantic cache. I will try to add these two links. So here you can study like how you can use the MongoDB for semantic cache and vector store, and also for memory chain, all things. Okay, so have a look into it. But initially you should practice these things of whatever semantic cache or langchain LLM caching we are using. Okay, so it can be a very good exercise for you. Try to use more caching strategies or more caching providers like AstraDB, Cassandra, SQL Alchemy. Then you can try this MongoDB and this Redis vector library also. Okay, so I hope you have learned a lot of things in LLM related to LLM caching. If you like this video, please just leave a comment, or if you have any doubt, also leave a comment. Please share this video and stay tuned for a lot of different new things, new topics related to LLM or LangChain. Uh, so that's it. I hope you like this video. Thank you.